Hello, Assalamualaikum my students. Adil sir here. Welcome you again to our unit integration. First of all, I'm sorry we haven't any class for 2-3 days. It happened only because I was not feeling well. I was suffering from headache and fever. But now today I'm little bit feeling well. So we will go for our unit, that is integration. And today our topic is application of integration. We have already discussed the unit integration. Now we will try to manage the application of these integrals that we have already defined. So we will start our topic today from this remark first, and it will be based on, first we will analyze it on this graph, and after that we will write this remark. We know that first of all, if we have this x-axis and this is our y-axis, this is our origin, and if this is a curve, the curve is continuous from this ordinate x is equal to a to this x is equal to b. We know that this integral a to b from this x to this b, this curve y is equal to f of x dx. We know that it is actually the area that is bounded by these ordinates x is equal to a, x is equal to b, and this x-axis, and falls under the curve y is equal to fx. We have already proved this theorem that this actually represents the area that is under this region. So we have nothing to do with it. We have already proved it. So now, if we have now the curve that is given us from the below of this x-axis, and it is continuous from this x is equal to a to this x is equal to b, and we have to find out the area that is on this curve bounded by these x-axis, x is equal to a and x is equal to b. How we can find that? We know that this is our first quadrant, this is our second, this is third, and this is fourth. We know that in first quadrant we have already discussed that the area is equal to this very formula. Now, if we have the curve that is falling in fourth quadrant, at that time the area of the curve is equal to a to b, just a to b. But at that time the curve is below, so our area is equal to minus times f of x. Or you can say that a to b minus y dx. So this is our area when the curve is in fourth quadrant. Now, if our curve is given continuous in the second quadrant, and we have to find out the area from this x is equal to a and x is equal to b, x is equal to a, x is equal to b, but the curve is here. At that time, the area is again equal to a to b from this point to this point, this one, f of x dx. So, but now if our curve is like this, if our curve is in first quadrant or in second, and like this is our curve, for example, and we have to find out the area from this point of y-axis, that is on y-axis, and to this point that is also on y-axis, that is from this point y is equal to a and y is equal to b. At that time the area is equal to, this area is equal to integral of a to b, this here curve. At that time you have to change the curve here. We are taking limits from a to b that are on y-axis, so our integral should be also in this dy. So here you have to change the function. If you are going that equal to y is equal to f of x, you have to find out from this equation the value of this x, and that time the area will be equal to a to b x d x dx. So this is our x dy. So you have to find the area like this. Similarly, for the fourth quadrant, you have to follow the same procedure. Now we will go for our remark. That is not in our syllabus, but we will just find out this remark. That is, if we have a circle and its origin if we have a circle, this is our circle, and if so organ 0, 0, if the radius of the circle from this if we will take this origin as center of the circle at that time, and if we take the radius of the circle as r, so radius of circle r, and for example this point is p of x y, p of x y. So here I am taking a circle whose center I am supposing the origin, that is 0, 0, and radius I am taking as r. Now we know that the radius of the circle is the distance from the origin to the circumference, and that is always equal, that is always same. So now the distance OP, that is radius, I am taking as r. But the distance, by the distance formula, you know that the distance OP is equal to, by distance formula, x minus 0 का whole square plus y minus 0 का whole square, and this OP I am taking radius, so it will be equal to radius, so r equal to under root of x minus 0 का whole square, that is x square plus y square. So now here if I will square on both sides, it will be here r square is equal to x square plus y square. So I am getting, if I have a circle and whose center is this origin 0, 0 and radius is r, at that time I am getting this curve equals to the point. We know that this circle is actually the locus of this point p of x y, such that the distance from the origin to that point is equal to, is same always. So here when I have considered the point on this, I am getting x square plus y square is equal to r square. This is called the equation of the circle when radius is r and the center is 0, 0 origin. Now sometimes if we have now a circle and its center is, for example here a comma b is the center of the, and radius r, this is my radius of the circle, and this is my p of x y, that means point on the circle. So here it is the circle like this. I am taking a circle, I am taking its radius as r, and center I am taking it as a comma b, where this a is the this abscissa and this b is ordinate. Now what is the equation of the circle at that time if our center is not now origin? So we know that again, this, for example, this is my t now, so we know that this tp is actually the radius, so tp is equal to r radius, but this tp by the distance formula it is equal to under root of x minus a का whole square plus y minus b का whole square is equal to this r. When I will square on both sides, it will be come out as x minus a का whole square plus y minus b का whole square is equal to r square. This is the equation of circle when r, this is the curve, this circle, when we have origin as a comma b here, and r if we have a center as a comma b, and if radius at that time is r, then the equation of the circle is this. If now the circle has radius r but center at 0 origin, so at that time the equation of the circle is this. So we will now write the general case, because in general case you can sometimes when your center is at or then you will put the a as 0 and b is equal to 0, you will get the equation of circle at center. So now you write the remark. I'm not still feeling good, but today you have to manage, and I will try my best to make you all the things clear here. But so you write down show that equation of circle with center at a comma b and radius r is this thing x minus a का whole square y minus b का whole square is equal to r square. So you write down this, and now you write it's true. Take this circle that way. So you take your origin a comma b, and you take it b, x comma y, and this is your radius r. We know that this actually the circle is the locus of a point, such that the distance from the center to the point is always same. So now you write true. We have this we have this PM equals to radius, that is equal to r, but by distance formula that you have already got from the unit coordinate geometry in 10th, by distance formula, this PM equals to under root of this x minus a का whole square plus y minus b का whole square. So therefore, from first and the second, what here PM and PM are same, so these two will be also same. So under root of x minus a का whole square plus y minus b का whole square, that is equal to this r. Now I will square on both sides, so I will get here x minus a का whole square plus y minus b का whole square is equal to squaring of this will be r square. So hence proved this is my equation of circle when our center is at A. And now we have the first result here, that is based on the application of integration, and we will solve that. You write it as result first, or you will write it as lemma, or you can write it as theorem also. So you write down, you know that we have from our birth we know that the area of, everyone was telling us that the area of the circle is pi r square. Now today we are going to prove it, that the area that's under the circumference, this boundary, that is called pi r square. What is r is radius, and pi we know that that's 22 divided by 7 approximately. So you write down first result. So from here we are going to start the unit. So you write down, prove that why this r is right. So you write down the proof. We take a circle whose radius r and we take its center at this origin 0, 0. For example, this is my circle whose center is now this origin and radius is r. And I have to find the area of this circle. Area of this circle, or I have to prove it. The area of this circle is equal to pi r square. This is a very beautiful result. You take this point as P, this one as M, with R, this value here is R, and you take this as O. You check here. Clearly, the area of this circle is equal to the area of this part POM and PO this part and this part and this part. But we know that these all parts are equal. Why? Because we have the center at origin, and we know that in circle the distance from the origin to this bone is always same. So here, when our center is at origin, these are x-axis, this x-axis and y-axis, they are perpendicular to each other. Then clearly, all the parts here from this OPM and these parts must be equal. So I can say that this area of circle, it is clearly equal to this part plus this part plus this part plus, but all the parts are equal. So can I write this area of this circle is equal to 4 times of this area POM, because PO. So here area of this circle is now equal to 4 POM. Now we can apply our application of integral. The formula there is the definite integral from a to b f of x dx is equal to the area under area bounded by the ordinates and the x-axis falling under the curve. So now you write the proof. In proof you write, we know that here you write a circle also. See your origin. So R, and this is your PM, PO, M. So you are taking this as P1. Now we know that equation of circle, I have already given you that so it is equal to now equation, it is equal to this x square plus y square is equal to r square. So here you can write down y square is equal to, this is my equation of equal, you can write y square, I will transpose this x square to RHS, so it will be r square minus x square. Now you check here y square, so here I will transpose the square, so it will come out as r square minus x square plus minus, but so here is plus minus, so you write down this first equation first. Now area of circle equals to area of this circle equals to, I have told you how that is equal to 4 times the area of this region. So you write it 4 times area of this one PO. So now you got up to here. You got area of circle equals 4 times area of POM. But we know by the application of derivatives, by the area theorem, that this area is equal to 0 to r, integral from 0 to r y dx. So it will be equals 4 times 0 to r, because the bounds are from the 0 and 0 to r y dx. But this is equal to now area 4 times 0 to r. We have this y equals to here, y equals to under root of I have already done r square minus x square. How? Because you have this x square plus y square is equal to r square, so you transpose this x square to the right, and then you got the value of this y as r square minus. So here I can write this y as under root of r square minus x square dx. This is my formula. We have already proved it that the integral equals to this under root of a square minus x square dx is equal to, we have that formula, but here it is now a as r square. So we know that integral of this a square minus x square dx, it is equal to x divided by 2 under root of a square minus x square, and then we have plus a square divided by 2 sine inverse of x divided by r. This is our formula, this integral. I have already given you its proof, so now you can apply here. It will be equal to 4. Now we have x divided by 2, so it will be x divided by 2, then a square, then this r square minus x square, plus we have then a square divided by 2, so it will be a square divided by 2 sine inverse of x divided by r. So you write here sine inverse of x divided by r. Now this is equal to, but the limits are from 0 to r. We know that by the fundamental theorem of integral calculus, that this is equal to, we have to substitute the value of this r, we have to substitute the x as r, and then we have to subtract the value of this when we will substitute this x equal to 0. So by the fundamental theorem you can write here 4 equals to x is r, so r divided by 2, then r square minus x is r, so r square plus a square, that is, sorry, r square, because a is equal to here r square divided by 2, and then sine inverse x divided by r, x we have r divided by r, suppose, and we have to subtract it, this from we have to subtract from this minus this one, the value of this when x is equal to 0. So it will be 0 divided by r, 0 divided by 2, sorry, under root of 0 minus 0, r square minus 0 square, and then plus minus this one is r square divided by 2, r square divided by 2, and then sine inverse of 0 divided by r up to here. So here it will be equal to 4 times r square minus r square, that is equal to 0, and 0 into finite value, that is equal to 0, so it will be now here 0 plus r square divided by 2, here it is sine inverse of 1 r divided by r, that is 1, sine inverse 1, minus, you check here, it is 0 divided by 2, 0 into something, that is again 0, but here it is minus r square divided by 2, so it will be minus r square divided by 2 and sine inverse of 0 divided by r, that is 0. So up to here I am getting area of circle equals to 4 times this 0 plus, and that is again, and then r square divided by 2 sine inverse 1 minus this is 0, now r square divided by 2 sine inverse 0. It will be equal to beta 4 times r square divided by 2 sine inverse of 1. We know that sine 90 is equal to 1. Here sine 90 is equal to 1. So I can write instead of this 1 as sine 90, that is sine of 90, that is pi divided by 2, and then minus r square divided by 2 sine inverse of 0. We know that sine 0 is equal to 0, so we can write here sine 0. The sine inverse and sine, they will get cancelled. Here I am getting 4 r square divided by 2 into this pi divided by 2 minus r square divided by 2. This one and this one get, I am getting 0 into 0. It will be 4. Here you check, it is r square pi, that is pi r square 2 into 2, that is 4, minus r square divided by 2 into 0, that is 0. So now you check here, 4 is multiplied as well as divided, so 4 and 4 will get cancelled. I am getting pi r square. So I am getting area of circle is equal to pi r square. This is the proof. Hence proof, better you write. Hence proof. Make it fast. Inshallah Rahman, this is enough for today because I am not feeling well. So Inshallah Rahman, tomorrow we are going to find the area of ellipus, area of parabola, area under parabola and under ellipus, and so many other results and formulas also we will prove tomorrow. This is enough for today. Hope you have enjoyed the class, and sorry if there is any inconvenience because of my illness. So you have to manage today this unit. Inshallah tomorrow we will go for